Dear students, let us start with the chapter of design of welded joints. And today's lecture is about the introduction of welded joints. Welding is the art of joining metals by pressure and heating to a plastic or semi-molten state, or of joining the metals by fusion only. The figure shows a fillet welding as is shown here. Okay. It is used in the construction of frames, housings, connecting members, and all types of machinery. It is also used for lightweight designing. Standard ruled shapes such as channels, T-beams, or I-beams may be used to the advantage in the welded structures. It is used in the construction of pressure drums for boilers, refineries, and other chemical processes. Next is cost of welding. The cost includes the cost of materials, say the structural steel, cost of cutting and forming parts, cost of positioning parts, welding, and then the subsequent machining. Overall, this cost may be less than the cost required for castings and forgings for many of the applications. As in the case of casting process, there is a requirement of patterns, molds, and there is a cost for casting and subsequent machining. Whereas in the forging process, there is additional requirements of dies, and cost of forging and machining is to be taken into account. So overall, welding may appear to be a cheaper option. Then is serviceability. Strength requirements are favored by welding of the structural steel parts. So if our material is low carbon steel preferably, and there is a requirement of strength, then we should go for welding. Deflection requirements are favored by large sections of castings. Damping capacity is met by the large volumes of cast and forged parts. So this is a guideline, and it tells that for strength requirements we should go for welding. Welding as a replacement of riveting. In certain applications, riveting is replaced by welding, as welded joints have more strength. They are lighter in weight. Cost of holding parts during welding and cost of welding is less than that required for riveting. No drilling of holes required. Welding is less time consuming, and designing of welded joints is quite easy. Welding is also used in repairing. Welding can be easily and economically employed to reunite metal at a crack. We can fill a crack. To build up a small part that has broken off, such as gear tooth, we can build a single tooth if it is broken. To repair a worn surface, such as blade of a hydraulic turbine, so if the blade surface is pitted or it has some damage, we can repair it. And as a surface of bearing, we can do the welding and increase the hardness for that localized region to increase the bearing. Now let us discuss the weld cross section and the terminology. Say the two plates A and B are joined by V groove butt joint. So this is the weld cross section. In this cross section, if I show different regions of the weld, so this portion which is protruded is the reinforcement. So this is the reinforcement. And in this point is the toe of the weld, and this top surface is the face. This is the face. If we show, this is the which is equal to the thickness of the plates is called throat. And this opening at the bottom is called root. Moreover, while welding, there is a heat affected zone around the weld, which is, if we take this, it is heat affected zone. So if I show the heat affected zone is somewhat like this, we can show this is the heat affected zone for the weld. And sometimes to prevent the or to retain the molten puddle in place while welding, we add a backing plate at the bottom. The backing plate may be of the same material or of different material. If the backing plate is of the same material, then it may get welded with the weld section. So what we can do is we have to either remove it or by cutting or and grinding, or if there is no problem, we can keep it in the same position or keep it with the weld and the welding form if there is no problem in the remaining of the this backing. Now reinforcement is basically, we say this height is reinforcement. So this completes the terminology for the weld section and the heat affected zone. Now let us discuss the weld cross section for a fillet weld. So for a fillet weld, say we have made a fillet weld here. So this shows, blue shows the fillet weld outline. So this is the weld outline. Same, this protrusion over the weld line, this is known as reinforcement. and we can show this cross section. Let me take different color pen. The pen is green. So this dimension, this shows the throat of the, this shows the throat of the fillet weld. And if we show the heat affected zone, the heat affected zone around the fillet weld is this. So this is the heat affected zone around the fillet weld. Let me erase this. And the toe of the fillet is, this is the toe of the fillet weld. So this is all about the terminology for a fillet weld cross section along with the. Now let us discuss some different welded joints. A welded joint is a combination of parts fastened together by means of a weld. There are 5 types of welded joints: butt joint, edge joint, lap joint, corner joint, and T-joint. In the next slide, we will discuss these. In the butt joint, we will place the 2 plates like this. Say this is the first plate. This is the first plate. Say we will be leaving a gap for the penetration. Say we are making a square joint with no groove. This is A plate and this is the B plate. Then we do the welding, and this shows, this portion shows the weld area. Now there are different types of weld cross sections which we can achieve is, that is, we can make a groove on the plates. Say this is the first plate, this is the second plate. Say what we have done is, we have made a bevel edge on one side of a plate, and we can make single bevel butt joint here. So if I show, this is a, if I show this is the, now this is single bevel butt joint. And this one was the square butt joint. Similarly, continuing with the butt joints, different type of butt joints. Say we have a plate, 2 plates are to be joined. What we did, we prepared the V grooves for the 2 plates. We prepared the V grooves like this. Like this, there will be certain reinforcement, Then this is known as single V butt joint. If thickness is more, we can go for double V. Say thickness is more, we will prepare the V grooves on both sides. We will prepare the V groove on both sides. The included angle between the V grooves is like this. Now this is double V butt joint. The included angle between the two plates is 60 degree. This V groove is made at an angle of 60 degree. Then we may prepare in place of V, U or J joint. So let us prepare. One plate is like this. On the another plate, we prepared a J groove, and that is known as so. Now let us show. We prepared a J. Cross section of this type of weld, this is single J. Cross section of this type of weld area is less, but strength is the same, but the groove preparation is costly in this case. So now similarly we can prepare double J like this. One plate is as it is. On the another plate we did the welding, we prepared J groove, double J groove. So this is known as double J butt joint. Now we can prepare the grooves for both the plates. We can prepare the groove for both the plates. We may say that single or double. We had the plates joined here, so now we will have a single or double U joint. So we create like this. Welding will be done like this. This is single U butt joint. Here we have prepared the U at the top and the bottom, both sides, for larger thickness plates for proper penetration. So this is a double U butt joint. Next is the edge joint. In the case of edge joints, we have the two plates placed parallel to each other. Say this is the first plate A, another plate is like this, say it is bent. Now what we do, we prepare the edges by grinding, and then we put a weld here. So, or we may have prepared the grooves. So this is the edge joint. Next is the lap joint. In the lap joint, we have the two plates like this. Now we will put the fillet weld here. If we put like this, if we put single fillet, this is single fillet lap joint, and if we do the welding on both the side, here and here, so this is a double fillet. Now I have made double fillet lap joint. This is the lap joint. So we have to rub it. So now we select the pen. This is the double fillet lap joint. We also discussed single fillet lap joint. Next is the corner joint. In the corner joints, we will discuss half open and full open corner joints. So in the case of half open corner joint, say one plate is like this, another plate is like this. Say this is the cross section we are showing of the plates. Then what we do is we put the fillet weld here with the reinforcement. So this is a half open corner joint. Now let us make full open corner joint. In the full open corner joint, The two plates are placed like this. If we show the section, now the fillet is placed. Fillet is placed here. This I am showing reinforcement. So this is the full open corner joint. This is the half open corner joint. Now is the T joint. In the T joint, what we have is, say this is the one plate vertical and another plate is horizontal, say like this. Say I show the cross sections. Then we place the fillets. We make double fillet like this. So like this. This is the double fillet. Fillet T joint. Now how the welding is done in different welded joints. We may do it in a parallel seam, means this is the top plate. Placed over and another plate. Let these plates are subjected to certain load. Pull P in this direction. So if we do the welding, we do the welding parallel to the application of load here, fillets like this. This is a parallel seam. Next is transverse seam. Same figure we have to make. This is the top plate. We apply a load P. It is to be welded. Design tells how much overlapping is to be done between the two plates. This is the top plate or bottom plate. We apply a pull P. Then what is done to be done is we put the fillets. We put the fillets in the direction transverse to, or welding is done transverse to the direction of application of load. This is a transverse seam. Then is compound seam. It is a mix, say this is the top plate, I have shown like this. This is the bottom plate. So these are the plates. Then these pulls are acting in these directions. when we put the fillets both parallel seam fillet welds parallel to the load direction and in a direction transverse to the load, this is known as compound seam joint. Then is the skew seam joint. In this joint, say we have the two plates subjected to certain load. I have to show the plates, how the plates are edges are prepared and joined together. Let us put the weld in a direction inclined to the load, say like this. So this is a skew seam joint. Next is the slot joint. In this, what we do is, in the top plate we prepare a slot like this. This is the bottom plate. Say the load direction is this. Slot is usually less wider. So what we do is, now we put the weld here, welding here in the slot. So this is known as slot weld. Then is the transfusion weld. In this we have the top plate, in the top plate we prepare to say two grooves like this. This is the bottom plate. Now we apply a pull P. Now the welding is done. Here this is known as transfusion welding. So with this we have discussed many type of weld joints, and in the next lecture we will discuss the representation of welds in the drawings. Thanks my dear students.